In this video, we are going to do a bit of review of determinants. So this is coming from chapter 3 in the text. And the standard that this corresponds to is M4. M4 is about computing the determinant of a matrix and being able to apply it to determine whether a matrix is invertible or not. Okay. All right, just as a quick review, remember that when you take a determinant, if that determinant is not 0, well, that's equivalent to the matrix A being invertible. So when the determinant is not 0, that means the matrix is invertible. But if the determinant was 0, then the matrix would not be invertible. Okay, so let's do a practice problem. This is coming from one of our worksheets. Okay, I got this matrix. I want to compute its determinant either by doing a cofactor expansion or row reduction. Okay, so first, I want to give you an opportunity to try this problem. So pause the video for about 2 to 3 minutes to try this on your own first. May not be enough time to finish the question, but that's okay. I mostly want you to be thinking about, well, what are the key ideas? How do I begin? How do I do something like this? So 4, 3, 2, 1, pause the video. Pause it and try it for about 2 to 3 minutes. All right, so hopefully you did that. Hopefully you paused the video to try this. Okay, so we could do it either way, the cofactor expansion way or the row reduction way. So one thing I noticed is that there is, just as review, remember that when we do a cofactor expansion, sorry, I meant to draw. When we do a cofactor expansion, we have to think about what the signs are. There's a sign associated with every entry. So the top left corner has a positive associated with it, and then it alternates. So along the row, then it'd be a minus, and then a plus, and then dot, dot, dot. It keeps switching. So in the next row, below the positive, it'd be a negative, and then it keeps alternating. Then it'd be positive, and then a negative, and then dot, dot, dot. And then it keeps going like that. So it keeps alternating. So I'll put dot, dot, dots, going down. It keeps going like that. It keeps alternating signs like this. So I'm going to do this by cofactor expansion, but we could definitely do it the row reduction way as well. When we do cofactor expansion, we pick a row or a column to expand it along. And the best choice for this problem, I think, is column 3, just because it has the most number of zeros, and that'll simplify our computation. Okay, so let's do that. So the determinant of A, so I take the first entry of that column, which is 0, and it gets multiplied by a determinant. So I'm going to put these absolute value bars. Remember, that's just notation for a determinant. And what goes in that determinant is, well, I'm focusing on this first entry, this 0. So I cross out the column that the 0's in, and I cross out the row that the 0's in. And everything that's left over, I put them into a matrix. So I see the 0, the 2, the 1, and then 1, 9, 3, and then 0, 4, 3. Okay. The other thing that I have to keep track of, what's the sign associated? Whoops, sorry. What is the sign associated with this entry? Well, this first 1 was a positive, and then the 8 would have been a negative. And then that means the 0 has a positive. Let's put a positive sign in front. Okay, now I move on to the next entry, which is this next 0. So I put its sign, which would be a minus sign in front of it. Okay, and then that'll get multiplied by a determinant. And what goes in the determinant is what I get if I cross out, so here's the 0 I'm focusing on, cross out the column it's in, cross out the row that it's in, and write all those remaining numbers. It turns out I don't really need to write them. I'll just put a squiggly line because it's going to get multiplied by 0, so it's just going to be 0. Okay, so that's really nice. Let me keep going. All right, so next entry. The next entry in that column is the 2. So I'll put the 2. Keep on alternating the signs. So that next sign should be a plus. This time I do actually need to put the entries in there because I'm multiplying by 2. So I cross out the column the 2 is in. I cross out the row it's in. And what I'm left with is 1, 8, 5, 0, 2, 1, 0, 4, 3. All right, let's move on to the last entry of that column, which is this bottom 0. So I'll do 0, keep on alternating the sign, so this should have a minus in front of it. And then I'll get a determinant. But again, it doesn't really matter what's inside of it because, well, 0 times anything is just 0. This just equals 0, and this one just equals 0, and this one just equals 0. So that's nice. That makes my computation a lot quicker. There's just one determinant I need to do. I still got to figure out this 3 by 3 determinant. And I can do that by also doing a cofactor expansion. So I have to pick either a row or a column to expand along. I think the best choice is the first column, just because it's got the most number of zeros. So if we do that, we get, well, there's still that 2 out in front. I'll put a big old bracket. So I take the first entry in that column, which is 1. The sign of the top left corner is a positive. I put a positive there. And that'll get multiplied by a determinant of what's left over if I cross out the column that the 1 is part of and cross out the row that it's part of. If I do that, we'll be left with the numbers 2, 1, 4, 3. Nice. Then I move on to the next entry of that column, which is 0. Its sign is going to be a minus. It doesn't really matter what's in that determinant because multiplying by 0 will be 0. And then I get plus that last 0 entry. That'll get multiplied by some determinant. And I close my bracket. All right, so, well, 0 times something is just 0. Same thing with this. That's 0. So now I'm just left with one final 2 by 2 determinant to do. So this is going to be 2 times 1. And the way I do a 2 by 2 determinant is I multiply these diagonal entries. 2 times 3 is 6. And then I subtract what I get when I multiply the other 2 diagonal entries. 1 times 4 is 4. Nice. That's how we do a 2 by 2 determinant. So we get 2 times 1 times 2, which is 4. Awesome. So that is the determinant of this matrix. And not that the question asked it, but if it asked me, is the matrix invertible or not? Well, because the determinant is not 0, that would mean it is invertible. Okay, so that is it for this video. It's also a good idea to look at other practice problems to review, well, how does the row reduction method for computing a determinant work?